So how do you resolve circuit? Resolution of circuit. So circuits can be connected in parallel and series, right? Parallel and series. So, and what we mean by circuit here is the resistors of the circuit, right? The resistors can be connected in parallel and series. And when you connect them in parallel, the in parallel connection, the total resistance is given by 1 over R, which is R total, will be equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus dot 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 1 over Rn to any numbers. While in series, we have, are you here? R is equal to R1, that is the R total. The equivalent resistance is going to be, are you here? I hope it's not blocking that part. Did it show up to this part? Just leave it. Consider. Are we here? R1 plus R2 plus R3, isn't it? Alright. So now listen very carefully. In order to resolve any circuit, first identify junctions. Because the way you resolve it then, if you resolved other circuits like that, if you resolved circuits normally like that, and you were told to find the current, if you're given current that was flowing in the circuit, you're told to find current in each circuit, you will make mistake by because you have to flow, you have to resolve circuits across each resistor, resolve current across each resistor using following Kirchhoff's law. Do you know Kirchhoff's law? Kirchhoff's law states that the total amount of current that is leaving a junction is equal to the total amount of current that enters the junction. So you have to, in other words, it means you have to identify junctions. You have to identify what? Junctions. So this is a junction, this is a junction. Now, this is a junction and this is a junction. Is that okay? Right. Regardless of this, what do you say? So what did we say last? We said to identify junctions. So this is a junction, this is a junction, this is a junction. So with this one, where would the junctions be? Where again? There is a junction. This. This is a junction. You get it? Why is this not a junction? Because it will be connected in parallel with this guy. Alright, here. What are the junctions? This. Where? Here. So this is a junction and this is a junction. Do you understand? So now listen. Anyone that is within the same junction, within two junctions, they are in series. That's the trick. Then anyone that is in different junctions, they're in parallel, regardless of the way they appear. So for example, these guys are within the same junction. No, now these guys are across junctions. They are not within junctions. They are across junctions. So these are in parallel, isn't it? So let's resolve this guy in parallel. So we're gonna have 1 over R is equal to, you can name it R1, R2, R3, R4 if you want to do so, but let's just solve it directly. So 1 over R will be equal to what? 1 over R will be equal to 1 over 2 plus 1 over 2 plus 1 over 3. So this is 1. 1 over 1 over 3. R equal to 4 over 3. Do you get what I did? Half plus half. 1. 1 plus 1 over 3. 1 over 1 over 3. That's 3. 3 times 1. 3 plus 1. 4 over 3. You get that? So R will be able to equal to what? 3 over 4. Which is 0.75 that you did then. Yes. So now we resolve this. Now the next thing to resolve is this. This is a junction here, right? So this place breaks these two apart. So what do we do to them? We resolve in parallel. You understand? So let's resolve this in parallel. That was what you did. So we have 1 over R because what? 1 over 3 was 1 over 3. That will be 2 over 3, right? So R will be equal to 3 over 2. And 3 over 2 is what? Okay, let's just leave it like this, 3 over 2, because we're going to still be solving it. So what we have here is what? 3 over 2, and what we have here at the end of the day is what? 3 over 4 ohms. Alright. Then, so with this, we now have these three guys to be in what? Series. Do you understand? So we'll now resolve this in series. To resolve this in series, where do we write that? Which one? Yeah, God bless you. So it means that this guy, this guy, this guy, and this guy are now in series. Do you understand? So that becomes R will now be equal to 4, no, 3 over 4 plus 4 ohms plus 3 over 2 ohms plus 2 ohms. Isn't it? Alright. Friends, you can see. This was the 6. So 6 plus this 3 over 4, right? Yes. So LCM of 1 is 4. 3 plus 6, isn't it? Alright, so we have 6 plus this 9 over 4, right? So this and this 1 remain 2 remainder 1. So 2 plus this, that will be what? 8. 8 to number 1 over 4 ohms. So or you say or 8.25. Do you understand? You see, I didn't change anything here. Did you see your mistake now? What's your mistake? What did you get? Your mistake was here. You did 0.5, 1.5. Check. But do you understand what I did? So do you understand what I'm saying? So, and at each point, now listen, if you are given this thing in theory as a theoretical question, that you are asked to show you're working, are you listening? At each point that you break down, for example, after breaking this piece down, your circuit is going to look like this, and then this will now become one resistor here, which is now 3 over 4 ohms. You get it? Then connected to 4 and this and this and this and this. Then as you are resolving, you keep compressing the circuit. Do you understand? Until you have one straight one, which is to be resolved in series. Do you understand? Right. So let's clean this one and solve the second one. But this second one, we messed it up. Yeah, we messed it up. So the first thing to do, so which ones can we resolve together first? So these two, they are in what? Parallel. So what you do is this. Let's resolve this in parallel. We have 1 over R will be equal to what? 1 over 4 plus 1 over 2. So this becomes 1 over R is equal to, do you know the theorem of, no, don't worry. Hey boy, yeah, you see it. 6 over 8. Do you know how I got it? LCM of this and this. I made it 8, but it's not 8 anyways. So then here, you see this guy, there are 2, this guy 4, 4 plus 2, 6. So the idea is this. Do underneath, do 4 times 2. Whenever you have something like this, you die. When you're adding 2 fractions, that the numerators are 1. So just multiply this and come up and add them. That gives us 6 over 8. And if you work that, so this is going to give us 2 here, 3, 2 here, 3, and 2 here, 4. So R will be equal to 4 over 3 ohms, isn't it? Because 1 over R is 3 over 4, so R equals 3 over. So we resolved this. So our circuit has now changed to this portion alone is now 4 over 3 or 1.3, right? Then to 4 to 3 ohms, then to this 3 ohms again, 4 ohms again. Do you get it? So this circuit has been reduced, compressed or reduced in a way. So in this way, we now have this. So we can resolve this in series, the answers in parallel. Did you get that now? So because they are within the same junction, do you get it now? Within the same junction, I told you series, within the same junction series. So we can resolve this together and this together. So when we resolve this, we're going to have R will be equal to 4 plus 3, and that's what? 7 ohms. Then for these guys, R, let's in down R1, R to be equal to 3 plus 3, that will be 6 ohms. Alright. So in parallel now, so this is series, and in parallel, what do we have? 1 over r because of 1 over 7, because here we got 7, right? Altogether, here we got 6 altogether. So in parallel now, it was 1 over 6. So from what I showed you, what do we have? 42 and 13. You got that? Okay. So r now we got what? 42 over 13. That's for this place. So since we have resolved them together, everything is 9 what? Series. So what do we have? What did we get here? 4 r will now be equal to 4 over 3 ohms, which is what we got here, plus 3 ohms plus 42 over 13. LCM of this, 39. 13 times 4, that will be 52. Is that 52? Yes. Then plus no, let's add only this. We'll do this one as an old number. Maybe this 3. Okay, yeah. 3 times 42, that will be 126. So 126 plus 52, what does that give us? 178. So we have 178 over 39, and that will be what? Can 13 divide it? 169 plus 13. Okay, now. Alright, so what do we have? Use your calculator to solve this guy. 178 by 39. Then plus 3 whole number. So that becomes and resolve into fraction. Press
AB.
Yeah. Answer is equal to wait.
178 minus AB.
Okay, what did you get? 4 points what? Just tell me what you got. 4.56, right? Alright, that one plus 3. That becomes 7 whole number. 56 over 100. That will be 5.6, yeah? I mean 5.6. 20 over 39, okay. I wanted to know. But anyways, this is the answer altogether. Did you get it? Alright. So for this one, we're going to be stopping here. Do well to subscribe to the channel if you have not already. Solve this video. Solve this. I said solve this video. Solve this question. Alright, but let me take you through the way you're going to solve it. Go and sit down and do your work. So you have this 1 over here, 2. So what you do is, this is a junction and this is another junction. So you resolve this in series, then the answer in parallel, then this again in parallel, then your answers all together in series. And that will be it. See you in the next video.
Thank you.